Okay, now in this question, we're being told we want to make X. And what I kind of like about this question is that in organic chemistry, uh, being able to synthesize things is really at the core of it, and having some understanding of that is important. So, and we're told the starting materials now. They're just named up here. So now, obviously, the important thing first of all is to have a look at the structure and try and differentiate what's different about it. Now, if we look here, we see this is really this red part here, and obviously the amine over here ends up becoming part of an amide link there, and then at the very end we've got this part here, which is here. So if we can really tell them apart, that's important. So one, we form an amide link. Two, we notice that the Cl has gone and been replaced with a double bond, so we go from a Cl to a carbonyl, which obviously we're thinking about oxidation of a secondary alcohol. We have a double bond here, which is gone here, so the double bond, the DB, is gone. And the methyl groups are still there, and everything else in fact seems reasonably the same. So we just have to work that out. Now just getting rid of that, so we've identified some of the differences between X, and so what we need to change. The first thing obviously we might think is that, gosh, if we need to get this reacted with this, but obviously equally that could be reacted with this, or third, finally, those two could be reacted together. Now I think a reasonable thought to think about is the fact that it seems likely that when we finally react the amine and make that join here, the amide link here, that's probably going to be one of the last reactions we do. So irrespective, there's an element of trial and error in trying to see if you can go through a process of creating something without creating any other unnecessary reactions. So if you're going to oxidize something, maybe you want to think about oxidizing it later than earlier, or whatever it might be. And so just looking at this, if we have if we wanted to basically bond this onto the structure here, we have to consider a couple of things. The double bond has to go, and the Cl has to be replaced with a ketone group. So at this stage we're thinking, well, we need to go from a Cl to a C double bond O, so that means we need to convert that to a alcohol. So is there a substitution reaction we can do for that? And for the amine, how do we create a how do we add it to the double bond? Is there a step in between that, so that we basically add something to the double bond and we then do a substitution reaction? You've got to be able to think about this, and your knowledge of the reactions is very important. For instance, just knowing the amine reactions is very helpful. Now we consider amine reactions. They undergo acid-base reactions. Substitution, where you can remove a halogen and substitute it with a primary amine, or depending on whatever you've got. Haloalkanes seem to be a little bit more versatile in reaction schemes, where if there's an OH group, you can create an OH group by substituting X here stands for any halogen. So you can substitute that for an OH in aqueous conditions, and you can substitute an X for an amine if it's an ethanol, and elimination reaction can also be done in alcoholic conditions. So in this case, when we're wanting to go from a Cl to a C double bond O, we need to, this one here would seem to be the obvious one. We're going to substitute the halogen for an OH to create a alcohol, which can then be reacted to make this. So that's one of those. And how do we go from this to adding an amine across a double bond? Well, first of all, if we can swap a halogen for an amine, if we can add a halogen across the double bond and put it there, then we can do it. So the obvious thing here would be, how do we get halogen onto a double bond in order to get the amine there? And that would obviously be an addition reaction. So if we have that, and obviously one of the reactants there is HCl. So if we were to do this and add HCl, that would add across this, and we would get as one of the products sorry, it's taking a little while there. We'd get HCl now. So, and then we could obviously swap that with the CH3NH2. Now, what I haven't done here, obviously, is considered the Cl, which is here. We want to remove that and react that to make a alcohol, and then from the alcohol to oxidize it. So the conditions for that would be, so in looking at these, this one down here, if we were to get rid of the Cl and replace it with the alcohol, we'd need to, out of the reactants we've got, we'd need to use NaOH aqueous. That would create this alcohol group, and then we could oxidize that, and that would create the carbonyl group. Now, in the first one on this side, we'd use HCl, and then we'd just react it with CH3NH2 to get the amine added across that. The question you need to ask yourself is, does the order matter? Is it best to do the HCl reaction first, or is it best to do the NaOH aqueous reaction first? Now, if we were to do the HCl reaction first, we would get chlorine there, and if we were then to do the NaOH reaction, then we would get both chlorines being substituted for OH and then oxidized. So it would seem to make sense to do the NaOH reaction first, then to react it with HCl, and not worry about oxidizing it at this stage. Okay. Now, you may think it's a good idea to oxidize it, but just try a little bit of trial and error in this and see if you can work your way through it. Okay, now just drawing this out, just one thing, when we do these rings, some of the things we sometimes ignore is effect. For instance, on the CH3, on this actually, if we were to draw it out, is a carbon, the CH3 group, there'd be another H there, and that would carry on. We're not showing the extra H's at all these points. Okay, so don't be confused by that. Often in rings we get so used to ignoring some of the H's there, they are there, we're just not always drawing them in. Okay, on this structure I'm not drawing them all in. There's, for instance, another one there as well. Okay, so they're all over the place. You just have to be able to count to 4 and know that when there's only, it shows 3 bonds, that there is actually a hydrogen that we're not showing. Right, so this is substituting the Cl here for an OH, and we're then adding across the double bond here with HCl, and I've left the OH here. Now it's possible we could oxidize it here. I'm leaving that. Now obviously I already know what the answer is going to be, but it wouldn't be the end of the world at this stage if I did oxidize it and then have to come back and change it, if you have a basic understanding of what's going on. Okay, now if we carry on, all I've done here is draw in, as we continue, oops, that's not been drawn in correctly though, just a second. That's not obviously NH2 there, that's just a force of habit. That's got to be an N. Now remember, N only bonds to 3 things. So that's got the CH3 there. We've just substituted that out with the amine group. And this is one of the first reactants that we're going to need for completing this. So now we move on to the second one involving the other reactant. Now the preferred way to, obviously when we're looking at this starting reactant, we have to consider that we're trying to create an amide link here, how these two are going to somehow get together. And one of the ways you've been taught is an amine plus an acid chloride is the preferred way. An amine and acid is a way that can be done, but obviously when we're talking about amine and acid, there's a chance of an acid-base reaction, and this tends to be the preferred way. So we need to turn this into a acid chloride first, and then from there we can then react it with the amine directly, and that should give us the product that we want. So when we do that, we add SOCl2 and we get this acid chloride, which then, if it combines with this, will make the following. Okay, now we're almost finished with this. We still have the OH group here, which obviously we can use dichromate to get rid of, and that will obviously change that. Now, one thing we have to take care of, the reason we didn't use dichromate earlier, is because it is acidified. If we have a base present, it may react with that, and we really don't want that to happen. So at this stage, now that we've got the amide link, that really isn't going to happen. So that's why we left it to this stage. So we just have to redraw the final struct, which is this here. Now one concern I have is the fact that you may not be familiar with what this ring means. So I'm just going to draw it out and fill that. It means it goes to a carbon, goes to here, it goes to a CH3, which hasn't been done, that's not done very well. And off the same carbon we've got a hydrogen, and then that goes to a carbon, which is double bond O, which goes to a carbon, which goes out, which is a CH3, to an H, and that comes to another carbon, which now has got an H, and that goes back there, and this goes back to the N with a CH3. So that's just drawing out that ring in full. Often we use the kind of shorthand and don't explain it, but that's what that is. It's the shorthand way of kind of writing these ring structures here and here. Okay, and that's that question.